Hello everyone, myself Amit A. My research title is Exploring Anthocyanin TiO2 Disensitized Solar Cell to Harvest Solar Energy. Abstract: Titanium dioxide thin films prepared on conductive FTO glass substrate by chemical bath deposition method. The XRD method is used to study the structure of TiO2 thin film. XRD analysis has confirmed amorphous nature of TiO2. The surface morphology of the thin film is studied by using FSM. The optical properties are studied using the UV visible and photoluminescence spectroscopy. The band gap of prepared titanium dioxide thin film is 2.48 eV. Anthocyanin is used as dye for dye-sensitized solar cell. A photoelectrochemical cell analysis shows that the conversion efficiency of 3.42% with a fill factor of 45%. Outline: TiO2 thin films prepared by simple chemical bath deposition method. In the optical, structural, morphological, and electrical properties of TiO2, photoelectrodes were studied by characterizing the film by UV visible optical absorption spectroscopy, X-ray diffraction, scanning electron microscopy, photoluminescence, and energy of activation calculated by using two probe conductive setup. Fabrication of TiO2 film. The chemicals were used for the preparation of thin film of standard gas sigma Aldrich, which includes TiCl3 liquid ammonia. The solution prepared by using double distilled water, TiO2 molecules were added on EFTO substrate. EFTO substrate is playing a vital role in TiO2 nanoparticles. The growth: we have used conducting EFTO glass slides having the dimension 75 into 25 into 1.35 mm for the dimension of TiO2 thin films. The cleaning of substrate was done by keeping the beaker containing chromic acid. The liquid ammonia maintained pH of the solution between the range 0 to 2.5. For the prepared solution, put in oil bath. Finally, clean the conductive FTO glass substrate were vertically positioned with the help of substrate holder. The oil bath was then subjected at room temperature. The deposited TiO2 thin films having concentration 1.00 m. During this time, it is observed the complete deposition on the slides taken out, followed by washing distilled water with several times and dry room temperature. Finally, the deposited TiO2 will get added thin film ready for the different characterization. For dye sensitized solar cell application, here we used anthocyanin as a dye. The anthocyanin pigments containing panic granium recorded the highest efficiency of 1.86 in 2012. However, still remaining space for the further development in the performance of natural dye sensitized solar cell. Strawberries containing anthocyanin pigment, which is red purple color, which get attached to the thin films. These are the chemical reactions: hydrolysis of TiCl3, ionization, hydrolysis of the secondary ion. And next is that same analysis. It shows many crack and creamy like morphology developed on thin films. Next is photoluminescence analysis. The calculated activation energy using the slope of the above Arrhenius plot of the TiO2 thin film is 0.18 eV. The TiO2 thin films clearly indicate that the n-type semiconductor in nature. Next is the UV spectroscopy analysis. The value obtained for the optical band gap is 2.48 eV. XRD, X-ray diffraction. The diffraction pattern shows that peak 101 plane of anatase phase of TiO2 matches with the standard JCPDS card number 01-0562. X-ray analysis shows the amorphous and nanoparticle nature of the TiO2. No peaks are observed in rutile or brookite phase, practically seen in the X-ray diffraction pattern. And photoelectrochemical PEC of TiO2. The measurement of PEC data ex- exposed a stable power conservation efficiency to 3.24% when open circuit voltage 425 MV, a short circuit current 18.0 mA per centimeter square, and fill factor is 0.45 or 45% of TiO2 thin film. The conservation power efficiency of TiO2 exhibit a good candidate material for the solar cell application. Thank you.
जाऊ देत.